So if you've got like the sun, and then you've got a planet out there, and then you've got another planet over there. Okay, so like the acceleration on, let me number things a little differently. Okay, so if that's body 1, body 2, and body 3, then we can talk about the acceleration on body 2 due to body 1, that is on Mercury. Mercury's the first planet, right? On Mercury due to the sun. Um, right, so should somehow be pointing in the direction of the sun, because the idea is that like the sun pulls the planet towards itself, right? And then like conversely, A12, the acceleration on body A12, the acceleration on body 1 due to Mercury is pointing in the direction of um, Mercury, because like Mercury pulls the sun a little bit towards itself. And so similarly, like the acceleration on body 3 due to body 1 goes that way, the other A13 goes the other way, A32 goes that way, and so on, right? So like there's really a directionality to all of this. And so the formula that we said before gives you the magnitude of the vector, how much it pulls, like how much gravitational force there is, but there's still the like fact that there's a directionality to think about here. So the formula taking into account the directionality is that as a vector, the vector acceleration AI is, we can do the same kinds of things, and so we get the sum over, like the vector sum now, over j's of the vector aij and the vector aij is, determined in the same way as before, except what we get is the scalar quantity g mj over the distance between I and j squared, where this is something called the magnitude of a vector. So what's the magnitude of a vector? It's like how big the vector is. So we take g mj over the magnitude of dij squared, and then we multiply that by dij hat, which is what's called the unit vector in the direction from body I, from body, let's see, if we want the acceleration on I due to j. It's the direction from uh, body I to, from body j to body, from body j to body I, right? Because like, for example, d sun earth is supposed to be the acceleration on the sun due to the earth, and so you want that to be pointing from the earth, right? On the sun due to the earth, you want that to be pointing from the sun to the earth in that direction. Okay, I think I got that right. If not, it's the reverse of what I just said. All right, so the point then is that we end up with a formula as vectors that tells you that the acceleration on body I is some vector formula here in terms of these quantities. So what we're going to need to do in the next segment is to develop some technology for working with vectors so that we can say something like this. But then once we've done that, then we can kind of just type in this formula as an operation on vectors, and we'll get like as an operation on vectors, we'll get a formula that we can type in to calculate these accelerations. Okay, more in a bit.